The Mojave Desert has been hiding a secret that moves faster than a bullet. While the world was distracted by Chinese spy balloons drifting over Montana and Russian threats in Eastern Europe, American engineers were quietly shattering the ultimate speed barrier. This wasn't a satellite, it wasn't a UFO, it was a project so classified that its existence was denied for over a decade. But the denials have finally stopped. The SR-72 isn't just a concept anymore. It isn't just a drawing on a Lockheed Martin whiteboard. It is the Air Force's answer to a threat that keeps the Pentagon awake at night. For 25 years, we thought the legendary SR-71 Blackbird was the peak of aviation. We thought Mach 3 was the limit of what was practical. We were wrong. Lockheed Martin's Skunk Works, the legendary division that built the U-2 and the stealth fighter, has been building its successor in the dark, a machine designed to fly not at Mach 3, but at Mach 6. That is 4,600 miles per hour. That is New York to London in under 1 hour. At that speed, the rules of engagement change completely. You don't just outrun missiles. You outrun the enemy's ability to even think. You outrun the command loop itself. But before we reveal how American engineers solved a physics problem that should be impossible, you need to understand why this aircraft exists. The answer connects directly to a dangerous gap in our defenses over the Pacific Ocean. A gap that satellites can't fix and drones can't survive. Welcome to the cutting edge of military aviation. Today's story isn't just about a new spy plane. It's about a technological leap so massive that it turns the entire planet into a 1-hour flight zone. If you think American aerospace should always lead the pack, type Mach 6 in the comments below. When the SR-71 Blackbird retired in 1998, the United States lost a capability it never replaced. We traded raw speed for stealth. We traded human pilots for spy satellites. Logic at the time seemed sound. Why risk a pilot over hostile territory when a multi-billion-dollar satellite can take a picture from orbit? For 2 decades, while we fought insurgents in the Middle East, that strategy worked. But the battlefield has changed. We are no longer fighting insurgents with AK-47s. We are facing peer competitors like China and Russia, and against them, satellites have a fatal flaw: predictability. Satellites follow fixed orbits that are governed by math. Our adversaries know exactly when they are passing overhead. They have apps that track American spy satellites. China has mastered the art of hide and seek. They roll their mobile missile launchers, the DF-21 and DF-26 carrier killers, out of caves after the satellite passes. They set up, they prepare to fire, and they disappear back underground before the next American satellite comes over the horizon. We are legally blind for hours at a time. This is called the intelligence gap. In a potential conflict over Taiwan, that gap could be fatal. An entire Chinese invasion fleet could move, or a missile barrage could launch, while our eyes are looking the other way. We need persistent surveillance in denied airspace. We need eyes on the target, not in 3 hours, but in 30 minutes. We need an aircraft that can launch from California, sprint across the Pacific, and photograph a specific street corner in Beijing before the dust even settles. And we need it to survive the most dense air defense network on the planet. Subsonic drones like the Global Hawk are sitting ducks against modern surface-to-air missiles. Even stealth drones can be engaged if they stay loitering for too long. The only answer is speed, extreme speed. But building an aircraft that can survive Mach 6 required solving the thermal thicket. That's the barrier where air friction becomes so intense it melts aluminum like butter and turns air into plasma. To cross that barrier, Skunk Works had to invent an engine that effectively breathes fire. To understand the SR-72, you have to look at who is building it. Lockheed Martin's Advanced Development Programs, better known as the Skunk Works. This is the team that Kelly Johnson founded. They built the U-2 spy plane in 8 months. They built the SR-71 Blackbird using slide rules and titanium bought from the Soviet Union. They built the F-117 Nighthawk, the world's first stealth fighter, using 1970s computer power. They have a history of doing the impossible. For the last 20 years, rumors have circulated about a project called Aurora. People reported seeing donuts on a rope, contrails in the sky. Seismologists picked up skyquakes, sonic booms that didn't match any known aircraft. The Air Force denied everything. But Skunk Works has a motto: Be quick, be quiet, and be on time. While the internet debated conspiracy theories, Skunk Works engineers were quietly working on the math for hypersonic flight. The SR-71 was designed to fly at Mach 3.2. It leaked fuel on the runway because the airframe had to expand inches during flight just to seal the tanks. It was a maintenance nightmare. The SR-72 had to be different. It had to be reliable. It had to be unmanned. Removing the pilot solves two massive problems. First, biology. A human pilot limits how many Gs you can pull and how long you can fly. At Mach 6, a turn takes hundreds of miles. Second, politics. If an unmanned SR-72 is shot down, it's a loss of technology, not a prisoner of war crisis. It's a machine, not a Gary Powers incident. This freedom allowed engineers to push the design to the absolute limit. For years, the SR-72 was just a rumor, a line item in budget reports that disappeared as quickly as it appeared. But then, the proof landed right in front of our faces, and it happened in the most American way possible. A summer blockbuster movie. When Top Gun Maverick hit theaters, aviation nerds lost their minds over the opening scene. Maverick pilots a hypersonic test aircraft called Darkstar. It hits Mach 10. It looks incredible. It features a sleek waverider design with canted vertical stabilizers. But here's the part that should make you sit up straight. That wasn't a CGI model built by a Hollywood special effects team. The aircraft in the movie was designed and built by Lockheed Martin's Skunk Works. They actually built a full-scale model and towed it out to the runway for filming. Why would a top-secret defense contractor spend millions building a prop for a Tom Cruise movie? The answer is simple. They were showing off. They were signaling. Lockheed CEO James Taiclet posted on LinkedIn shortly after the premiere. He didn't call it fiction. He wrote, "Darkstar's capabilities could be more than mere fiction. They could be reality." That is a subtle way of telling our adversaries that the technology is already here. And China took the hint. Intelligence reports leaked that while the movie prop was sitting outside on a test range for filming, the Chinese military actually retasked a spy satellite to photograph it. They thought it was the real thing. They maneuvered a strategic asset just to get a look at a movie prop. And frankly, they were right to be worried. Because what's under the hood of the real SR-72 is a nightmare for Beijing. To understand why the SR-72 is such an engineering miracle, you have to understand the physics problem that has stopped everyone else for 60 years. It's called the Propulsion Valley of Death. It is the gap between where a jet engine dies and a rocket engine begins. Here is the issue. Jet engines, like the ones on the F-22 or a 747, use spinning turbine blades to compress air. They are great for takeoff and landing, but if you push them past Mach 2.5, the physics breaks down. The air enters the engine so fast and so hot that it melts the turbine blades instantly. The shock waves choke the engine. You physically cannot fly faster with a turbine. To go faster, you need a ramjet or a scramjet. These engines have no moving parts. They use the sheer forward speed of the aircraft to compress air into the combustion chamber. They are incredibly efficient at Mach 5 or Mach 6, but there is a catch. A massive catch. A scramjet doesn't work at low speeds. It's like trying to light a match in a hurricane. You can't take off with a scramjet. It simply won't start until you are already flying at Mach 3. So you have a gap. Your turbine melts at Mach 2.5. Your scramjet doesn't start until Mach 3. That gap is the Valley of Death. Every previous attempt to bridge it failed, until now. Skunk Works developed the turbine-based combined cycle, TBCC. This is the holy grail of aerospace engineering. Think of it as two engines in one sharing the same inlet and exhaust. A traditional turbine sits inside a specialized housing. It powers the jet from the runway up to Mach 3. Then, in a mechanical ballet that happens in milliseconds, the engine geometry shifts. The turbine inlet closes off to protect the blades. The air is diverted into the scramjet duct. The afterburner turns into a ramjet combustion chamber. And suddenly, you aren't flying a jet anymore. You are riding a controlled explosion at the edge of space. Making this transition smooth, without the engine stalling or the aircraft breaking apart from the shockwave shift, is the hardest problem in aviation. And Lockheed Martin says they have solved it. Building an engine that works is only half the battle. The real problem at Mach 6 isn't aerodynamics, it's thermodynamics. Friction. At 4,600 miles per hour, the air doesn't just flow over the wings, it impacts them with such violence that it acts like sandpaper. The air molecules are compressed so tightly that they turn into plasma. The leading edges of the SR-72 will heat up to over 2,000 degrees Fahrenheit. This is the thermal thicket. At these temperatures, aluminum melts instantly. Titanium, the metal that made the SR-71 famous, begins to soften and lose structural integrity. The SR-71 had to be painted black to radiate heat. And even then, the cockpit glass got so hot the pilot couldn't touch it. But Mach 6 is exponentially hotter than Mach 3. If you built the SR-72 like a normal fighter jet, it would disintegrate before it even reached top speed. Skunk Works had to reinvent how an aircraft is built. They call it a warm structure. Instead of fighting the heat with heavy shielding like the space shuttle tiles, which are fragile and heavy, the SR-72 embraces it. The aircraft is likely built from advanced carbon-carbon composites and ceramic matrices. These are similar to materials used on hypersonic missile nose cones. But the real genius is the cooling system. The SR-72 uses its own fuel as a coolant. This is called regenerative cooling. Before the fuel is injected into the engine, it is circulated through microchannels just beneath the aircraft's skin. The superheated fuselage warms the fuel, and the fuel absorbs the heat from the fuselage. It's a perfect loop. The heat that tries to destroy the plane is used to preheat the fuel. Hot fuel burns better. It increases the efficiency of the scramjet. The aircraft literally uses the hostile environment to power itself. So why go to all this trouble? Why spend billions to fly at Mach 6? Because speed is the only stealth that doesn't expire. Stealth technology is a cat-and-mouse game. We build a stealth fighter. They build a better radar using low-frequency bands. Eventually, radar wins, but physics is harder to beat. An S-400 or S-500 missile battery works by tracking a target, calculating its future position, and launching an interceptor. It is a math problem. Against the SR-72, that math breaks down. By the time a radar operator in Beijing detects an SR-72, processes the track, and authorizes a launch, the aircraft has already moved 80 miles. The intercept geometry becomes impossible. The missile literally cannot fly fast enough to catch up to a target that is already leaving the kill zone. You can see it, but you can't hit it. And the SR-72 isn't just a spy plane. This is where the mission profile shifts from observation to action. Lockheed Martin has confirmed that the aircraft is designed to carry weapons, but not just any weapons, hypersonic missiles. This creates a new concept of warfare called ISR strike. Intelligence, surveillance, reconnaissance, and strike combined in one platform. When you drop a weapon from an aircraft already moving at Mach 6, you give it massive kinetic energy. The missile doesn't need a large booster rocket to get up to speed. The plane does the heavy lifting. It's like throwing a rock from a speeding car, but the car is moving at 4,000 miles per hour. A projectile hitting a target at that speed delivers force equivalent to a massive bomb purely through kinetic impact. It hits like a meteorite. This allows the SR-72 to penetrate deep into enemy territory. It can hunt down those mobile missile launchers. It can strike high-value command bunkers, and it can escape before the enemy even knows the war has started. We need the SR-72 because we are not the only ones racing for speed. Russia has deployed the Avangard hypersonic glide vehicle. China has the DFZF. Our adversaries have been focused on hypersonic missiles for a decade. They realized they couldn't beat the US Navy or Air Force in a fair fight, so they invested in speed to bypass our defenses. The SR-72 is America's answer, but it is a reusable answer. Missiles are expensive and one-time use. An aircraft can fly hundreds of missions. It can be recalled if the mission is aborted. It provides flexibility that a missile never can. The Air Force has officially stated they want a hypersonic demonstrator flying by the mid-2020s, but if history teaches us anything about Skunk Works, the public timeline is usually years behind reality. The F-117 flew for years before the public knew it existed. The SR-71 was a secret until LBJ announced it. There is a very real possibility that the Darkstar we saw in the movies is based on an aircraft that is already sitting in a hangar in Palmdale, California. Or perhaps it is already leaving contrails over the Pacific. The SR-71 Blackbird was a marvel of the 20th century. It flew faster and higher than anything else, and it never lost a single aircraft to enemy fire. But it was a product of the Cold War. It relied on analog computers and slide rules. The SR-72 is a product of the future. It relies on artificial intelligence, advanced ceramics, and scramjet physics. While China pours concrete to build stationary islands in the South China Sea, and Russia struggles to maintain its aging fleet, the United States has once again looked to the edge of physics for a solution. The Son of Blackbird proves that American aerospace dominance isn't just about stealth anymore. It's about combining stealth with speed that simply cannot be caught. We are entering an era where the timeline of war shrinks from days to minutes. An era where there are no safe havens, no hidden bunkers, and no denied airspace. If you can reach Mach 6, you own the sky. The Blackbird is dead. Long live the Darkstar. If you found this breakdown of the SR-72 valuable, hit that like button and subscribe. we bring you the latest on the military technology that keeps our nation safe. Drop a comment below. Do you think the SR-72 is already flying in secret, or is it still just a blueprint? Thanks for watching, and stay proud of what American innovation continues to achieve.